There's a quote stated by Dr. Ralph Mikko, which is, nanotechnology is an idea that most people simply do not believe. Why? Because nanotechnology is so small and we cannot see by using our naked eyes. It can only be observed under the electron microscope. So when we talk about nanotechnology, I think majority of us will think about this scene. So this is actually a scene in Avengers movie, and this hero named Iron Man has a suit that is made up of nanotechnology. So what is nanotechnology? In fact, nanotechnology is a branch of technology that deal with nanoparticles to produce new structures and devices. So before we start our presentation, I would like to introduce myself and my partner first. We are the cell and molecular biology students in University Putra, Malaysia, and my name is SIEW Sam, and I used to work as a part-time disinfection staff. In this job, I gained some knowledge about the application of nanotechnology in the disinfection field. So how about you, Dave?
So hi, my name is Liang, and before that I got work as a part-time pharmacy before, and I've known various ways and a few methods of drug introduced to our body.
Right. So the topic of our presentation is nanotechnology in animal health. We both have great interest on this topic, so we did some readings and research on articles from different universities about this topic, and now we would like to share with you what we have learned. So today, I would like to focus on two applications of nanotechnology in animal health. First, Dave will present about the application of smart drug delivery in animal health. And next, I will present about the disease diagnosis and treatments in animal health using nanotechnology.
Okay, so at first, I'll be presenting about smart drug delivery. But before that, I would like to compare the normal conventional drug delivery system and also the smart drug delivery system. A conventional drug delivery system is usually accompanied by a systemic side effect that mainly attribute to their non-specific biodistribution and uncontrollable drug release characteristic. But in smart controlled drug delivery system, they can effectively reduce the dosage frequency while maintaining the drug concentration in the targeted organ or tissue for a longer period. Although there's a tremendous number of publications about advanced drug delivery system, but only a little has been published on the relevance of safety and efficacy evaluation of smart drug delivery system in animal to be more predictive clinical effect on humans. So scientists believe that in the future, further technologies advance will make this smart drug delivery system most likely to develop delivery system for a biological and bioactive system for target site delivery capacity, such as potentially using buckyballs, nanotubes, and dendrimers on drugs and all those implantable cell bioreactors. Besides that, it can also develop nucleic acid delivery system through a bottom-up approach using DNA molecule to build nanowires or nanotubes in the assistance of reproduction, animal vaccine, and also animal control agents. But the above situation will only able to reach their full potential through integration. Next slide. So more research needs to be taken for them to work together and to design and develop automated integrated network for monitoring and control of animal system and food safety and security. The development of smart herd system that detects, identifies, report, and treats the illness of single infected animal in a herd prior to the onset of symptoms can also be considered. So next, I'll be passing to Sam for the next presenting topics.
So I will continue the next application of nanotechnology for disease diagnosis and treatments in animal health. There's a nanotechnology used for treatments of cancer called nanoshells. And nanoshells are a new type of nanoparticle that compose of a silica coated with an ultra-thin metallic, which is gold layer. So here are the steps of application of nanoshells for treatments of cancer. So firstly, nanoshell can be injected into animal blood. Secondly, the nanoshell in the blood will seek out and attach to the surface receptor of the cancer cell. And thirdly, when there is an exposure of infrared light, the cell temperature rises to about 55 degrees Celsius. And lastly, the high temperature can burn and kill the cancer cells. The normal cell that did not attach with this nanoshell will not be affected. So this is the research done by the scientists in Rice University, Texas. And here's the link for the article. If you are interested, feel free to check it out. So next, there is a nanotechnology used in disease detection. This nanotechnology is called biochips, and a biochip is a device typically made of hundreds or thousands of short strings of artificial DNA, and it deposited precisely on a silicon circuit. So firstly, biochips can be used for disease detection in animals. How? It can use to trace the source of food to detect the presence of animal products from different species. So it can locate the source of pathogens that lead to public health threats such as avian flu and mad cow disease. Next, biochips can also detect the quantities of proteins and chemicals in a sample. Hence, they are useful for detecting biowarfare agents or disease. And lastly, the biochips can be used to analyze and manipulate biological samples such as blood, tissues, and semens. So that's all from me. Thank you for paying your attention, and I will pass it to Dave.
Turning to the last part of the presentation, is nanotechnology overhyped, or will it change the world of animal health and veterinarian practice? Studies show that existing research has clearly demonstrated the feasibility of nanoshell and nanotubes for the introduction in animal system to seek out and destroy target cells. Application of smart drug delivery to monitor the effects of delivery seems to be quite effective in the future, and there is still more research to go for nanotechnology to reach its full potential. As mentioned by Sam, just nanotechnology can also used to diagnose and treat disease by injecting nanoparticles into animals, such as nanoshell, or using biochips to locate the certain pathogen and kill them. Although nanotechnology is still on its early stage of development, we can see that more scientists and biologists are beginning to work more deeply for significant benefits and in healthcare, animal medicine. Thus, it is reasonable to say that nanotechnology industries will begin to be revolutionizing animal health and medicine over the next couple of decades. Thank you.